All right, we are live. Algebra, or this is actually Precal12, my fault. Part 1, Precal12, Units 1 and 2. You'll hear a lot of people in here touching base on some questions. We're going to hop right into it because we only have just a little bit of time, about 30 minutes. So if you have any other questions, feel free. Monday, come on in. Right towards the end of school, we'll have a couple of hours we'll touch base on. Again, Precal12, review for the final, Part 1. All right, we're going to screen share here, and we're going to pull this up now at this time. And again, what we'll do is we're going to go through this together. And again, if people have questions, feel free to stop me, and we'll kind of go from there. All right. All right. Let's look at number 1. And if you have your review sheet, that if you're at home, I would take that out. That might be beneficial for you in that way. The first one states this: a projectile is fired from a cliff 200 feet above the water. So let's get a picture here. We've got a projectile being fired off like this. This is 200 feet high, and we are good on that. So now it says this: the water is given by, the way the actual parabola shape is given by h of x equals negative 0.32 x squared plus x plus 200. Now what it asks is this: number 1, how far from the base of the cliff is the height of the projectile a maximum? So what we want to do is find what the maximum is, and then determine how far away it is from the base of the cliff. So what are we looking for? Well, right here, if we could find what the maximum is, what we're doing is solving for the x of the maximum. So if we were to take our graphing calculator, and I'll take mine out here, I hope you do at home as well. Those are my YouTube followers. A little shout out to you, all 3 of you. That joke never gets old. Now, when I shoot it, one thing you might want to do is just kind of go to Zoom Standard or Zoom Fit. That probably would be better than the Zoom Standard there. So let's go Zoom Fit. And that will help us hopefully to be able to see it a little bit better on that screen. So as we go towards it, you'll notice that your parabola is given within your screenshot. Now, what we want to do is be able to solve for what that maximum is. So if you go to second trace, which is calculate, second trace, then go to maximum, which is, I believe, number 4, it'll ask what the left bound is and right bound is. Well, with left bound, you want to try to make sure that you kind of hit on this side. You want to make sure you go maybe to the left of it as well as to the right of it. So left bound, press enter, and then go to the right of where you think the maximum is, press enter. And then you want to make sure that you graph it. So let's go again. Let's go make sure I've got it. Boom. And we're going to guess right in the middle. And my maximum was 1.56, comma, 200.78. Okay, so that right there was where it's at. So for A, my answer is 1.56 because we're looking for how far it was from the base of the cliff. Now, B asks this: what is the maximum height of the projectile? Well, we just saw for the maximum, our height is related to our Y. Therefore, our B would be 200.78. Okay, so that would be it, 200.78. Now, for C, it asks, how far from the base of the cliff will the projectile strike the water? Well, anybody in the crowd tell me, how do I solve for that? How would I figure that out? That's exactly right. Caleb Christ, all the way from Topeka, Kansas, knows that the 0 will end up being what the x-intercept will be. Nicely done. So now we'll go to the 0. We'll go left bound, right bound. So we want to go above the x-axis for the left bound, and then below the x-axis for the right bound, and then try to guess in the middle. And we know the 0 is 26.6. comma 0. So how many feet is it? Well, we got 26.6 feet for our C. Okay. And then our last one says, when the height of the projectile is 100 feet above the water, how far is it from the cliff? Well, remember that the height is related with the Y, right? So if we put in 100 in for the height, what we're saying is when is this equation right here going to be equal to 100? Well, simply, all we're looking for is if you end up solving or setting it equal to 0, subtracting 100, what you'll get now is this will be 100 right there, okay, on that right side. So everything's the same when you go into your equation, except now put in 100. And what you're going to do now is when you graph it, now since the equation's changed, you're going to solve where it crosses the x-axis again. And when it does, that's where the that's how far from the base of the cliff the height is 100 feet. So when we do that now, we go left bound and right bound again, hit the middle, and I got 19.31 or 19.3 feet away from the base of the cliff when it's at 100 feet. So what we're saying is if this is 100 feet high, we know that the feet from the base of the cliff would be 19.3 feet. Okay?
Wait, so for the 100 one, you basically just subtract 100 from the 200. You plug in 100, subtract it from 200, and then you do zeros?
Correct.
Okay.
Yeah, because now what we've done is what the high cliff that we've done, now we've changed that to where now we're saying if it was at 100 feet, it'd hit the ground, right?
Okay.
But it was at 200. So what we're going to do is we're going to shrink down the cliff, okay, just like we'll smash down the Play-Doh cliff. And then now it's at 100 where it hits the x-axis. That's now our new height from the base of the cliff there. That make sense? All right. Questions on number one. Number one was a little tough one, but not too bad, all right? Now the next one, number two, is one that states write the polynomial function that has a degree of 4. What does degree 4 mean?
Means it's going to have an x to the fourth in it.
Yeah, x to the fourth will be our highest exponent, right? That's what the degree means.
And this is number 3, correct?
Correct. So if our zeros are -3, 0, and 2, 2 has a multiplicity of 2. What does multiplicity mean?
The amount of times it occurs as a 0.
Correct. So now we'll put 2 2's there. So now -3, 0, 2, and 2. So now if we were rewriting this, we'd have x plus 3 times x minus 2 times x minus 2. Okay? Now this is where the tough part occurs, because now what we've got to do is, we've got to figure out when we multiply out what we get out now. And really the tricky part is just multiplying out. Once I get here, I think it's pretty simple to get to here. Now it's just trying to figure out when I get the zeros, what would be the equation. So x times x would be x squared. X times 3 is 3x. X minus 2 times x minus 2 would be x squared minus 4x plus 4. And so at this point right here, I would take that part where the arrow is, and now I'll just distribute out. So if I did that, I'd have x to the fourth minus 4x to the third plus 4x squared plus 3x to the third minus 12x squared plus 12x. So simplified would be x to the fourth minus x cubed minus 8x squared. Let's see here, plus 12x. And that right here, this one right here would be my answer right there. Okay? Now, again, I know that I went quickly through that, but that makes sense on how I would set it up and execute it.
You wouldn't need to pull out an x, would you?
Oh, great question. No, because what we're trying to do is get, it says write a polynomial function.
Okay.
So we want to just distribute it out to get only one. If we were to take out an x, we do the reverse of what we just did. Okay? All right. Yeah, go ahead. Go ahead, Colin. All right, let's go to the next one. We're on number 4 now. This one says that the revenue of a John Deere company. John Deere company. I want a tractor. I want a good tractor. Maybe we'll get a tractor for this room next year, you know?
Ooh.
Nice.
Where would you put it?
You just teach.
Where would I have so much room in here?
It's Coach Jay's.
Right there in the middle.
You could teach on the tractor.
They think about
Almost.
tractor 6.
That's exactly what I was thinking, Caleb. I was actually thinking that same thing.
And you
So
would come up with a stupid hashtag like hashtag tractor math.
is that tractor math or
And
tractor
you'd say-
tractor?
Instead of are we tracking, you say are we tractor? 'em?
That's right. My ice cream tractor, like Ice Cream Man.
My tractor brings the students to the class.
All right, let's talk over this next one. The next one talks about how the revenue of John Deere tractors is $200,100. Okay. Now, it asks what unit price would be associated with this revenue that was given. Well, since the revenue is this amount, what we're going to do is we're going to put $200,100, in for r of p. So this literally is being plugged in to where now we have negative 1/2 p squared plus 1900 p. Now, I don't want to go too far into this because I don't want to spend all that time in here. You know this, just like I did on the first one. Let's bring negative, we'll subtract 200,100 to the each side. And once I do that, how could I solve what unit price P would be associated with this revenue? How would I figure that out? You could use a quadratic, but you have your calculator too, right?
Oh, yes.
So what you could do is actually, we know it would be something that looks like this, right? So you could figure out where the zeros are.
Yeah.
Once you figure out where the zeros are, you know that the zeros will be associated with the unit price. Which one would be associated with the unit price here, left or right?
Right.
Why do you say that?
Because it's positive.
It's got to be positive. Very good. So when you do this, it's got to be the positive one, left bound, right bound, just like we did with maximum and zeros, and then we'll guess in the middle, and then we'll get out what that P unit price is. Okay?
Move 200,100 to the other side.
Correct. So it should look like this, right? And then I'll plug that in, get out the zeros. Correct. Plug and chug, and we'll be good. And you find the zeros on your graph of y equals there. Okay? All right, 6, 7, and 8. Are there any questions on 6, 7, and 8? I know I'm going fairly quickly through this. Any questions on 6, 7, and 8?
The only thing with i's is if it's negative I squared, or I squared is -1, right?
Correct. So, yeah, if I had I squared equals -1. For instance, if I was multiplying those first two on number 7, this is how it would look. It'd be negative I plus 3i squared. When simplified, would be negative I minus 3 because this I squared, it turns into a -1.
Now, if you have a negative I squared, would it turn into 1?
Correct. Yeah, negative I squared would
Just
turn into 1 there.
Cool.
Can we get a restroom?
You may. Go ahead. Go ahead, Sarah. All right, number 9. Let's look at that. Number 9, and then we can kind of touch base on number 10. Am I going too quick through these, or is this helpful? This good? Okay, good.
Sounds good.
I think this is better than what we did last year.
What did we do last year? Just go straight through it.
I don't think I reviewed as much like this in podcasting. I think it was more do it on your own type thing.
Parties.
Party in the USA. All right, so let's do this. We got a y-intercept and a x-intercept, okay? All right, now, with y and x-intercept, the easy thing to remember about this is when I solve for a y-intercept, I plug 0 in for x. It's always the opposite. And with x-intercept, we plug 0 in for y. So if I was looking at the first one, what I'd have is this. Y equals, we can plug y in for g of x within our function. -4. Let's go the other way. -4 times 0 plus 3 squared plus 5. Okay? Now 0 plus 3 should be 3 squared is 9. 9 times 4, -4 is -36. Add 5 to equal -31. So -31 would be my y-intercept. So let's put that in something we know. It should be 0, -31.
We got to multiply that.
Yeah, make sure you distribute that -4 once you solve for inside the parentheses, okay? Now the next one is if I was solving for the x-intercept is where you plug 0 in for y. So in this one, this becomes a little bit trickier because now we've got to figure out what satisfies the equation. So what we can do on this is kind of to help us out, we could take what the x-intercept is, plug 0 in for y. So we'd have 0 equals -4 times x plus 3 squared plus 5. All right? Now with this, what I would do is I would distribute completely out. Okay, so I would distribute it out there. One other thing you could do is subtract 5, divide by -4, square root, subtract 3, and all that. Does that make sense? So you could actually do that. Actually, now that I think about that, that might be easier, right?
Much easier.
Yeah. So let's do this. Let's subtract 5. So we're just solving now. So subtract 5. We'll have -5 equals -4 times x plus 3 squared. So we're going to divide by -4. So here's what I've got now. I should have, I'll put it up here. I'll bring it up yonder. 5 over 4 equals x plus 3 squared. So if I get rid of that squared, I'm going to square root both sides. And when I do, I'll have plus or minus the square root of 5 over 2 equals x plus 3. Because remember, we'll square root that bottom 4, which gets me to 2.
Subtract 3.
Exactly. Good, Chris. So subtract 3, negative 3 plus or minus the square root of 5 all over 2 equals x. That right there would end up being what my answer would be. Walk away, say booyah, and you're good to go. Okay, and you also could put comma 0. We know there's 2 x-intercepts in this case, so we could put that comma 0 just to say that that's our x-intercept.
The
All right.
answer is square root of 5 over 2 minus 2, plus or minus.
Yeah, I would do plus, it would be actually negative 3 plus or minus the square root of 5 all over 2. Because the plus or minus is associated with what it was being square rooted.
Got it.
All right. Word.
I
Word to your mama. All right. Number 10.
She says hi.
Oh, number 10. End behavior. Anyone need end behavior there?
I need to behave a little bit, but
Can you give us?
Yeah, I'll give you this right here.
it's even and positive negative as well.
Yeah, let's go. Yeah, even degree, negative LC, which is coefficient, negative lead coefficient and positive lead coefficient, odd and odd, negative lead coefficient and positive. So there's four different kinds. Even, where it's negative, means both fall, left and right. Even, where it's positive, both will what? Falcons rise up. Yeah. Both rise up, right, left. Okay. Had a good draft there.
Fake crowd noise in. We're good to go.
That's right. See what you did there. With the positive lead coefficient and its odd degree, will rise to the right and fall left. Negative lead coefficient will fall right and rise left. Okay. So again, just remember those right there. This right here will probably be something that we'll include on our note card.
And that's
with that,
that's looking at the exponent over the first x or exponent or variable. That's what I was trying to say.
correct. Okay. Correct. And also what I've decided is that today, like throughout this, numbers 1 through 10, I will be creating the note card for y'all so that you don't have, so we don't have to worry about someone trying to do that for us. It's because it'd be kind of confusing with everything. So the lead, with that lead coefficient test, we need that, don't we? That'd be a good thing to include, okay? So all I'm gonna do is I'm gonna star that one, any ones that we need. Could you look on numbers 1 through 10 and tell me maybe if you could use something that would be something you'd put on the note card from numbers 1 to 10. So even if you haven't been paying attention, you've been doing your review sheet, look on
the I-squared thing.
the I-squared, okay? I'll remember that one. I'll put that on there. Is there anything else you see that you could kind of touch base on? I actually didn't do number 5. I might want to do here. Is
That's
there?
just synthetic, right? You said like
Correct. Yeah, you
plug in
just use synthetic there.
2, and then is it like guesswork after that? Kind of like
Yeah.
figure out what the other one.
Yeah, if I just want to,
3 zeros.
if I just want to talk through number 5, you use 2 with synthetic first. Once you do that, you're going to get what your answer is out. Then with that answer, you'll use the quadratic equation to solve for number 5. Okay. Is there anything else that you see that you could use for a note card? Again, I'm all ears right here. Anyone see anything else?
It's the 0 that you put into the synthetic division, correct?
Correct.
Okay.
Correct. Yes. Do you
Really?
need just a reminder there?
Yeah, that'd be good because sometimes I get confused as to whether it's what we're subtracting from x or adding from x or if it's the 0.
All right. Zeros in synthetic. I can do that.
Mhm.
Anyone else? Anything else there? All right, very good. All right, so unit 1 is done. Okay, see how quickly that was? Not too bad. Again, please make sure, study the review. The review is a big, big deal for what we're going to put on the test, all right? Now, the next one, as we look at unit 2, since we're on that same kick, are there any formulas you'll see on unit 2? There's only 5 problems there. I'm guessing Asymptotes, whether like a whole, a VA, or HA, the different rules with that?
Yes.
Okay, we'll do that one. Are there any other ones that you see there? How about, I'm going to remind us about the X and Y intercepts too.
Will we have to deal with ln and e with these things?
I
Like
don't
with-
think this is the ln or e yet.
Like with number 4, you see you have a x in your raised.
Yeah, so that one right there, on that one, number 4,
Mm-hmm.
that one is going to be, that's a good one. We could go over, like, I could just say, hey, exponential has a horizontal asymptote. You know what I mean? Just to remind that.
Yeah.
And that will help us with that next one, okay? So I'll do that one on number 4. All right, and we'll do that, and we'll go from there, all right? So let's do this. Let's start with Unit 2. I think I've got all the formulas there. Do y'all have any questions on Unit 2 that we can go through together?
Let's do number 1 just to
Do it here?
Holes tend to not be fun.
Yeah, let's do that. All right, let's go. This one is x to the 3rd plus 2x squared minus 15x all over x squared plus 8x plus 15. So this is a function here. And what they're doing is they're saying with this rational expression, determine a couple things. Number 1, determine the HA, horizontal asymptote. Determine the VA, the vertical asymptote. And determine the holes, okay? Now let's go over the easier things first. First things first, with any time we have a vertical asymptote, that's where the bottom's equal to 0, right? So let's do this first. Let's first factor on the top and bottom. And I can do that. Let's put this in green so we can see it here. So the top we could factor out an x, leaving us with x squared plus 2x minus 15. And on the bottom, we could factor that bottom into what?
5 x plus 5 x plus 3.
5
Yeah,
and 3,
x plus 5, x plus 3. Very good. So I'm going to put that here. And on the top, I think we can also factor that as well, can't we?
X plus 5, x minus 3.
That's exactly right. Good, Chris. So I have x plus 5 and x plus 3 on the bottom, and now we are good to go. Now, before we end up finding what our bottom is equal to 0 for our VAs, what I do want to do is first figure out, are there any holes? Is there anything we could cancel on top and bottom? X plus 5. So we know that in our hole,
It's going to be minus negative.
x is not equal to
Negative 5.
-5. That is a hole. That means that when I approach it, I have a circle, and then it keeps going at -5 on my graph, if you remember that. Now, if there's nothing else we could cancel, whatever makes the bottom equal to 0 that's left over is now a VA. So now we know that it's a vertical asymptote, so we know it's going to be x equals, and we know the vertical asymptote will be what line?
-3.
Yeah, x equals -3. Also remember the hole this is not equal to, right? So make sure it's aligned through that. Now finally, we have our horizontal asymptote. With the horizontal, it's always y equals, okay? It will always be y equals. Now remember, there's 3 different rules, right? If the degree is higher on top than on the bottom, we know that there will be none. Okay, there's no horizontal asymptote. If degree is the same, you all remember what we do here? We divide, right? Divide lead coefficients of the highest degree. So if these were both the same, it'd be 1/1, which would be 1.
So for these, we're not looking at our factored equation. We're looking at our original equation.
Correct. Correct. And then finally, our next one is if degree is higher on bottom, we know that if it's higher on the bottom, then we will have y equals 0. Okay? Does that make sense? Now, the only kicker with this is this. If it is none and it's 1 degree higher on the top than the bottom, what do we have?
Slant.
we have a slant asymptote. Okay. Now, I'm not sure if I'm going to put one on there or not. If there is, there will only be one of them. Okay. And I might just say, hey, find the slant asymptote of this. You know what I mean? So I probably will do something like that. Or I'll make it like maybe not a multiple choice question, but just say, hey, fill in the blank and go from there. By the way, I am going to make some of them not matching. And I think that that's better, or not multiple choice. I think that's better for you. I find it that if you mess up a little bit,
You get psyched out.
exactly. So I don't want to do that to you. So I can't grade all of it because of time's sake, but it will be kind of half and half type of thing. Okay. So because of the HA, this will actually be none. And the slant asymptote is where we'll divide the bottom in for the top. Okay. Divide it into the top. Remember using the long division. So do we need to keep going here? Yeah.
Wouldn't hurt.
Yeah, let's do this. Let's put it, let's go to this one. Let's go right. Yeah, let's go right here. I'll do it small. X to the third plus 2x squared minus 15x plus 0 is divided by x squared plus 8x plus 15. Remember, we're not concerned with the remainder. Okay, so what times x squared equals x to the third? We know it's x. Multiply it out to get x to the third plus 8x squared plus 15x. Subtract all the way around to get negative 10x squared plus 0x. And so what times x squared equals negative 10x squared?
Wait.
Yeah, go ahead,
Isn't
Sam.
your 2x squared positive?
Yes, it is. You're right. So this should be negative 6, right? Thank you for saying that.
Yeah, I got it.
So then it would be what times x squared equals negative 6x squared? To be negative 6, right? Okay, so we have x minus 6. And once I get to here and I only have that whole number, I don't need to go any further. I know my slant asymptote will be y equals x minus 6. And so what I did right there, without having to graph it, I don't think it said graph it, but right there what I did was come up with my HA, VA holes, and my slant asymptote there. Sam?
I don't know if you can give us all of those rules about horizontal asymptotes, but for slant asymptotes, can you give us long division?
Yes. I can give all that.
If you
That's
can
fine.
give all that, that's great. And will we have to graph these on the exam?
Great question. I like number 3. That'd be a good one to try to do. You know what I mean?
Number 3 in unit 2.
Yeah. Unit 2
Okay.
is another good one. That I would just be ready to be able to graph them.
Got it.
Again, I might have one of those where you have to do everything, and just how much ever you can get down will be good by me. So, all right, questions? Right on. All right, what about number 2?
It's just factoring down and solving for x, right?
Yeah, that one. That's where on this one, this is a tough one. I'll be honest. This one's a tough one. If you were to take this, my whole goal is to take what you've been given. Let's say x to the 4th plus 10x cubed, whatever. And what you're going to do is graph it in your calculator. Okay. So it might look something like this, right?
I got you.
I don't know what it looks like, but you get the idea. You're trying to look for where it crosses the x-axis. So you'll find what the zeros are on that problem on number 2. Solve for where the zeros are. Use synthetic division. So let's say that one of these zeros was -1. Plug that in and plug in all the coefficients in front of the variables in descending order. Bring down the first one, and now just continue to multiply out. Once you get a remainder of 0, which you should, because again it was a 0, you'll do the next one, and then once you do both of those, you'll do the quadratic formula to solve for the last 2.
Sorry, how do we find -1 again? Zeros?
Yeah, you'll plug in your calculator, that equation, and solve for where the zeros are at. So once you solve for the zeros, should be good to go there. Okay, does that make sense, Chris?
Yes.
Then that's what you'll use for synthetic division on number 2. Okay. Number 3, I already went through a lot of the rules with. Are we good on number 3? All right, right on. What about number 4? I'm gonna go over number 4 real quick.
Sure.
I know that it's about time to leave, but we'll go over number 4. Y equals -3, x plus 2 with a negative 1 on the outside? Well, what I would do here is I would first, I know that this +2 and -1 are going to be some sort of transformation. I also know that this negative will be some sort of transformation. So if I just did y equals 3 to the x power and come up with a t-chart, that's going to help me with where I go from there. So if I plug in 0 and 3 to the 0 power, I get 1. If I plug in 1, I get 3 to the first power, which would be 3. Plug in 2, which would be 9, and so on and so forth. So remember, with an exponential, we'll have a horizontal asymptote at 0. We know that 0, 1 will be our point here. 1, 3 will be our point here. And 2, 9 will be way up here. So it should look something like this without any of the transformations. Well, what happens when you end up having a +2 with x? What will happen there?
You go up 2.
It'd be left 2, right? Because it's with x. So we'll go left 2, and that -1 on the outside will go down 1, right? Once I do that, because the negative's on the outside, I'll then reflect. So what I'll do is, again, what I'll have is this, and let me do this one. I'll go, this point will go left 2, down 1, left 2, down 1, and because what would normally be this way, here, again, this asymptote just went down 1 because of that -1 right here, just went down. But again, it's not this blue line. Why?
Because it's negative.
Yeah, because of the negative right here, it's reflected. Therefore, what we could do is just, if we reflect it over on itself, we should have it about right in here. Okay? Right on. Thank you very much, George. Hope that was helpful. We could go over this a little bit more on Unit 1 and 2.
I appreciate it.
Absolutely, anytime. It was a good yesterday.
Yeah, yes, sir.
Awesome. I was so bummed I couldn't make it.
Oh, no problem.
I really, really.
Yeah,
I
no
was
problem.
like, I've got something for it.
Oh,
Let me do this. Let
sweet.
me set this bad boy off.